Hello and welcome to the third of these short chats about fundamental mathematics, this time doing a few examples of this RMS average as it's applied to waveforms. First waveform to look at, this one. The value of the signal, in this particular case, this purple line here, is -2 the whole time. The value is always -2. So the mean value of this waveform is -2. And the mode is -2. And the median value is -2. But what's the RMS value? Well, we can work it out as before. The value of this waveform is always -2. So we take the formula. It's the square root of the sum over all possible values of the waveform squared times the probability that it has that value, and apply it in this case. Well, the waveform only has one value, and that value is -2, and the probability that the waveform is -2 is 1. It is always -2. So this summation is actually quite easy to do. We're just summing over one thing. So this is the sum over just one term, which is -2 squared times 1. Well, -2 squared is 4, so this would just be the square root of 4 or 2. So the RMS average of this waveform is 2, plus 2. The RMS value is always positive, because it's the positive square root of a square. So we have a waveform here, which has a mode, a median, and a mean, all of which are negative, but its RMS value is positive. Next one. Here, we've got a square wave, which is +2 for 1/3 of the time and -2 for 2/3 of the time. Well, if you can't instantly see what this is going to be in terms of its RMS, we could just apply the formula again. It's the square root of, and this time the waveform has two possible values. It can be +2, and the probability that it's +2 is 1/3. It's +2 for 1/3 of the time. It can also be -2. And the probability that it's -2 is 2/3. It's -2 for 2/3 of the time. Well, that I could write like this. 2 squared is 4 times 1/3. -2 squared is also 4 times 2/3. That just gives me the square root of 4 times 1/3 plus 2/3. But 1/3 plus 2/3 is 1. So that's just the square root of 4 or 2. Again, it's exactly the same RMS average as the previous waveform had. The shortcut to getting there is just to notice that the square of the value of this waveform is always 4. And if the square of the value is always 4, then the mean value of the square must be 4. So the RMS value is the square root of 4, it's just 2. Okay, on to the third example. This one slightly harder because the square of the waveform is no longer constant. For 1/3 of the time, the square is equal to 4. That's 2 squared. And for 2/3 of the time, the square is just 0. So we have to go back to the formula. Square root of. Now, the summation here, it's going to be 2 squared for 1/3 of the time, plus 0 squared for 2/3 of the time. That's the value squared times the probability, plus the value squared times the probability, just as before. Well, 0 squared is 0, so that term just disappears. We end up with the square root of 4 over 3, which is 2 divided by the square root of 3. And that's the RMS average of this one. Next. Okay, things are getting a little trickier now. This is a sine wave. Now, we can no longer apply the formula that we had before in exactly the same way, because this waveform can now take any value at all. So we can't do a simple summation over all possible values of the waveform. We have to do something slightly different. What we do is something like this. We write an equation for that waveform, and the equation would be x as a function of t is 2 times sine of omega t, angular frequency times time, so that this is a phase angle in radians. I'm taking the sine in radians here. I will usually do that. Things work out easier that way. What I want is the average value of the square of this waveform. First thing I do is square it. That would give me 4 times sine squared omega t. And now I have to go and apply a useful trigonometrical identity. I hope you've come across this one. It's the one that tells us that sine squared of an angle is 1 minus cosine of twice the angle divided by 2. I'll leave the maths lecturers to derive that one if you haven't come across it before. If not, you can either test it out yourself or just believe me. Using this, I can rewrite the square of my waveform in this form. X squared of t is 2 minus 2 times cosine 2 theta. Right. What's the average value of that? Well, the average value of 2 is just 2. I'll write the average value in this form again. The average value of this is the average value of 2 minus the average value of 2 cosine 2 theta. The average value of 2 is just 2. It's always 2, it's going to be 2, its mean, mode, median and RMS value are all going to be 2, it's just 2 all the time, its average is 2. Right, but the average value of this, well, that's a cosine wave. That's a wave that looks a bit similar to this. It oscillates up and down. It's above 0 for exactly the same amount of time that it's below 0. For every single possible value above 0, there is an equivalent point below 0. So its average, the average value of cosine of anything, is going to be 0. So the average value of this, the average value of 2 cosine 2 theta, is just 0. It's a cosine wave. It oscillates up and down. It's positive for the same amount of time as it's negative. Its average value is going to be 0. So the answer to this, what is the average value of the square of this waveform? The answer is 2. So the RMS value, which is the square root of the average value of the waveform, is just the square root of 2 in this case. We can make that more general. If we have any sine wave and it's centered around 0, then its RMS value is going to be its amplitude divided by the square root of 2. A is the amplitude. If the sine wave was looking like this, then this is A here. A lot of people learn that formula, that the RMS value is the 0 to peak amplitude divided by the square root of 2. But please remember that this only works for sine waves. For any other waveform, like those square waves we looked at earlier, this doesn't work. Sine waves only. And only sine waves which are symmetrical around 0, like this one is. Sine waves who have an average value of 0. What happens if our sine wave doesn't have an average value of 0? This one, perhaps. Now what? Once again, we can start in the same way. What we want is the average value of the square of this waveform. And then we take the square root of that to get the RMS. Let's write this waveform, x of t, as, well, we can write that as 1 plus sine omega t. Because this is a sine wave with a 0 to peak amplitude of 1 that's just been raised up by 1. So instead of going from -1 to +1, it's oscillating from 0 to 2. Sine omega t plus 1. So its minimum value is 0, and its maximum value, when sine omega t is 1, is 2. And that's the waveform that we have there. Right. So we square it, we take the average, and then we take the square root of that average. First job, square it. If I square it, I get 1 plus sine omega t all squared. Multiply out the brackets, I would get 1 plus 2 sine omega t plus sine squared omega t. And I want the average value of that lot. Okay. The average value of 1 is just 1. It's just constant 1 all the time. Its average is going to be 1. The average value of 2 times sine omega t is going to be 0, because that's a sine wave. If we had a look and see what that looked like, it would look like this. It would go above 0 and below 0. It would go up to 2, it would come down to -2, but the average value of this is 0 because it's positive for the same amount of time that it's negative. They would cancel out. The average value of sine squared omega t, however, we'd have to go back to that formula that we used last time. That is 1 minus cosine of 2 omega t divided by 2. So, in this particular case, that would give me a half minus cosine 2 omega t over 2. The average value of a half is just a half. The average value of cosine 2 omega 2 over a half is 0 again. Because if I drew out that waveform, it would look like this. It's a cosine wave. At twice the frequency of the sine wave up here, but it's a cosine wave, spends the same amount of time positive as it does negative. These cancel out. I would get 0. So the average value of this is just a half. Add these three together if I'm working out the averages, and I would get average value of 1 is 1. Average value of 2 sine omega t is 0. Average value of sine squared omega t is a half. Net result, 3 over 2. And my RMS average is going to be the square root of the mean value of the square. So it's the square root of all of this stuff, which gives me a final answer. It's the square root of 3 over 2. Okay, that's enough examples of RMS averages. Next time we'll look at a different subject, logarithms.